Hello and welcome back to e-sipnayan. For today's video, we are going to discuss transforming general to standard form. But before we proceed, do not forget to hit like, subscribe, and also hit the notification button below so that you'll get notified once we upload new videos. To start off, here is the learning objective that hopefully we're going to achieve at the end of this video. That is, you should be able to transform the general form of a circle to standard form or center radius form and vice versa. Let me now begin the discussion by presenting terms to remember. And the first term that you need to remember is the term general form. So when we say general form, it is represented by this equation, ax squared plus cy squared plus dx plus ey plus f equals 0. And we know that a, c, d, e, and f will have its corresponding numerical value later on. So how will we know that the given equation is in its general form? So basically, all terms should be on the left-hand side of the equation and it is always equated to 0. The next term that you need to remember is the term standard form. And standard form is represented by this equation, quantity x minus h squared plus quantity y minus k squared equals r squared. All conic sections have its corresponding standard form. And for a circle, this is the equation representing it in its standard form. So the standard form is the one used in graphing circle because the center can easily be identified as well as the radius. Moving on, let's try to answer this question. Why is there a need to change one form of equation to another? Specifically, why do we need to know how to transform general to standard form? The answer is because when we graph circles, the essential parts needed, such as the center and the radius, will only be easily identified once the equation is in its standard form. Let's now have examples on how to transform general to standard. So basically, for you to be able to transform general to standard form, you should be able to make this equation similar to the format of standard form. And here I listed some important concepts needed for you to efficiently do that. First, you should be familiar on how to perform completing the square. Next, you should be able to know how to operate algebraic expressions, particularly the fundamental operations addition, subtraction, multiplication, and division. And lastly, one handy concept that is very useful in doing the transformation is square of a binomial. Let's now proceed to the first example. To start off, we need something on the right-hand side of the equation, and usually the radius is represented by a constant. Therefore, we start transforming this equation to standard form by transposing negative 16 to the right-hand side of the equation. To start off, we need to transpose the constant to the right-hand side of the equation. So we are going to transpose negative 16. The equation will now be 4x squared plus 4y squared equals positive 16. We do not want any coefficient for x squared and y squared, that's why we need to eliminate 4. That's why we need to divide both sides of the equation by 4. On the left-hand side of the equation, we can write it as a sum of a fraction, and that can be written as 4x squared over 4 plus 4y squared over 4 equals 16 over 4. Afterwards, we need to simplify the left-hand side of the equation. We can cancel out the coefficient 4 for both of the terms. Hence, the equation will now become x squared plus y squared equals 16 over 4 or simply 4. Therefore, the standard form of the given example is x squared plus y squared equals 4. This equation by transposing again first the constant to the right-hand side of the equation. Hence, the equation will now become x squared plus y squared plus 8x minus 2y equals, from negative 8, it will now become positive 8. Our next goal is to make the equation similar to the standard form. So basically, we need to first group the terms with similar variables, and that would be x squared and positive 8x. So now, why are they considered as terms with similar variable? Because they both contain the x variable. Another terms with similar variables would be y squared and negative 2y. Afterwards, we need to rewrite the equation in such a way that the terms with similar variables will be beside each other. Hence, rewriting the equation in that way, we'll get x squared plus 8x plus y squared minus 2y equals 8. After rewriting the equation, this is now the process where we are going to complete the square. That's why it's important that we group the terms with similar variables. So let's group together using parentheses x squared and positive 8x, and also group together y squared and negative 2y. After which, we are now going to do completing the square. Let's first do completing the square on the terms with x variable. So let's copy the first two terms. We have x squared plus 8x. Now, in completing the square, the goal is to make a perfect square trinomial. And for us to be able to do that, I'll write here the equation. It is usually like this: b over 2 squared, where b is the middle term. And in this case, our middle term containing the x variable is 8. Hence, to complete the square, we need to apply the formula. So we are going to add b is 8, then divide it by 2, and then get the square. We are also going to apply the same process with the terms with y variable. So let's copy the operation, that is addition plus. Then again, copy the terms with y variable. That would be y squared minus 2y. And then to complete the square, we again apply the formula. And in this case, our b is 2. So what we're going to add is plus b is 2 divided by 2 and then square. Do not forget to group again the terms with like variables or with similar variables. So let's group together the x's and the y's. Since we are talking about an equation, of course, whatever we do to the left side of the equation, we also need to apply on the right-hand side of the equation. Hence, since we added two constants on the left-hand side of the equation, we're also going to add the same values on the right-hand side of the equation. Hence, the right-hand side of the equation will become equals 8 plus whatever we added on the left-hand side of the equation, which are plus 8 over 2 squared and plus 2 over 2 squared. Next, we are now going to simplify the left and right hand side of the equation. So this will now become x squared plus 8x. Let's now simplify 8 over 2 squared. 8 divided by 2 is 4. Squared is 16. So we are going to add plus 16. Then copy the operation addition. Copy y squared minus 2y. Then let's simplify 2 over 2 squared. That will now be 2 divided by 2. 1 squared is still 1. So we are going to add 1. Equals, the right hand side of the equation is 8 plus, we simplified this term as 16 a while ago, and then this term as 1. Then again, do not forget to group the terms with the same variable. So let's group the x's and let's group the y's. Afterwards, we can now perform or apply the concept of square of a binomial, or we can rather factor this perfect square trinomial. When we factor x squared plus 8x plus 16, the result will be x plus 4 squared. Likewise, we need to factor the terms with y variable. And when we factor that, the result will become y minus 1 squared. And then again, do not forget to copy the operation addition. Lastly, let's now simplify the right-hand side of the equation by adding all the constants. That will be 8 plus 16 plus 1. The result is 25. And if you notice, by doing all of the steps we did a while ago, we were able to achieve our goal to make it a standard form equation. So if you notice and compare it with the standard form equation here, it is now the same. So we have x minus h squared plus y minus k squared equals r squared. And the counterpart here would be x plus 4 squared plus y minus 1 squared equals 25. Hence, the standard form given the general form in this particular example would be this equation. And that is how you transform general to standard form. Let's now have another example, and this time we again start by transposing the constant to the right hand side of the equation. Hence, the equation will now become x squared plus y squared plus 6x minus 4y, and from positive 9, it will now be negative 9. And just like the previous examples, we need to group the terms with similar variables, and here it is x squared and 6x. They both have the same x variable, and also y squared and negative 4y. They both have the same y variable. Let's now rearrange the equation in such a way that these terms will be beside each other. So the formula or the equation will now be x squared plus 6x plus y squared minus 4y equals negative 9. Let's now use grouping symbols to group terms with the same variable. So let's group the x's and let's also group the y's. Then after that, we can now complete the square. Therefore, the equation will now become x squared plus 6x. To complete the square for the x variable, we're going to add 6 over 2 squared. And then to complete the square for the y terms, okay, let's copy the operation addition. Then y squared minus 4y. To complete the square, we're going to add, okay, we are going to add 4 over 2 squared equals to the right hand side of the equation, and of course whatever we add to the left side, we also add to the right side. So that will now be negative 9 plus what we first added is 6 over 2 squared, and then the second term we added is 4 over 2 squared. Moving on, let's now simplify, but before that, do not forget to group again the terms with the same variables, the x's and the y's. Let's now try to simplify what we added on x and y. So let's copy x squared plus 6x plus 6 over 2 squared is 3 squared plus y squared minus 4y. And then 4 divided by 2 is simply 2 squared equals negative 9 plus 3 squared plus 2 squared. Alright, next step is to further simplify those which can still be simplified, but then again, do not forget to group the terms with the same variables. Hence, the equation will now become x squared plus 6x plus 9, 3 squared is 9, plus, copy the operation, y squared minus 4y plus 2 squared is equal to 4. And then on the right hand side of the equation will now be negative 9 plus 9, another 9, plus 4. After which, for us to be able to factor, we need to group again those perfect square trinomials you obtained by completing the square. Hence, we can now factor x squared plus 6x plus 9. The factored form will be x plus 3 squared. Then copy the operation. And we can also factor y squared minus 4y plus 4 since it is a perfect square trinomial. And the factored form will become y. Okay, let me just write that. Y minus 2 squared. Next, on the right-hand side of the equation, we need to combine like terms or simplify. So negative 9 plus 9 is just 0. So we're just left with simply 4. And if you notice, this is already in the standard form. Hence, the standard form given this example is quantity x plus 3 squared plus quantity y minus 2 squared equals 4. And that is the standard form of this given equation. Let's now have another example, and again here we start by transposing the constant to the right hand side of the equation. Hence, the equation will now become x squared plus y squared minus 2x equals positive 15. And just like the previous examples, let us group together the terms with the same variable, which are x squared and negative 2x. If you notice, there are no other terms with variable y, so we leave y squared as is. Hence, we rewrite the equation as x squared minus 2x, and then we simply copy plus y squared equals 15. And then again, we group the x's or the terms with the same variable. In this case, it will be x squared minus 2x. Moving on, we can now proceed with completing the square. So we copy x squared minus 2x, and then what we're going to add would be, okay, we are going to add plus 2 divided by 2, then squared. Then we simply just copy the remaining terms of the equation, which are plus y squared equals 15. And again, whatever we add to the left-hand side of the equation, we also add to the right-hand side. So we have plus 2 over 2 squared. And again, never ever forget to group the terms with the same variables. In this case, it will be x squared minus 2x plus quantity 2 over 2 squared. Moving on, let's now simplify. So copy x squared minus 2x. Then 2 divided by 2 is simply 1 squared. Plus copy y squared equals 15 plus 1 squared. And also, again, do not forget to group the x's or the terms with the same variables. Moving on, we now simplify further the equation, so that will have x squared minus 2x plus 1 squared is simply 1 plus y squared equals 15 plus 1. So we are only going to apply completing the square once using the x variables or the terms with x variables. So let's now complete the square. X squared minus 2x plus 1. The factored form will be x minus 1 squared. Then we simply copy plus y squared equals, let's simplify the right hand side of the equation, that is 16. Hence, the standard form given this example is quantity x minus 1 squared plus y squared equals 16. Let's now proceed to the last example, and again we start by transposing the constant to the right hand side of the equation. Hence, the equation will now become x squared plus y squared minus 20x minus 2y equals negative 52. Then again, just like the previous examples, we group together the terms with the same variables. In this case, x squared will be grouped with negative 20x, and we group y squared and negative 2y. Let's now rewrite the equation in such a way that the like terms will be beside each other. So it will become x squared minus 20x plus y squared minus 2y equals a negative 52. Let's now use parentheses to formally group the like terms, or the terms with the same variable rather. That will be the x's and the y's. Moving on, we now proceed to completing the square. So copy x squared minus 20x. We are going now to add plus Okay, plus 20 over 2 squared. Then for the y's, copy the operation, plus y squared minus 2y. And then to complete the square, the term we are going to add would be plus 2 over 2 squared. And again, whatever we add to the left side of the equation, we also add to the right side. So that will become equals negative 52 plus the first term we added is 20 over 2 squared. And then another term we added is 2 over 2 squared. And again, do not forget to group the terms with or the terms having the same variables, the x's and the y's. Moving on, we now proceed to simplifying further the equation. So copy x squared minus 20x plus 20 divided by 2 is simply 10, then square, plus copy y squared minus 2y. Simplify 2 over 2, that's 1 squared, equals, on the right side, that's negative 52, plus 10 squared plus 1 squared. Simplifying further, we will now have the equation. Okay, after grouping again the x's and y's, the equations will now become x squared minus 20x and 10 squared is simply equal to 100. Copy the operation plus y squared minus 2y, and y, not y, but 1 squared is equal to 1, equals negative 52 plus 100 plus 1. Let's group again the x's and the y's so that we'll know what to factor. Then moving on, we now proceed to factoring. Let's factor x squared minus 20x plus 100. The factors will now be quantity x minus 10 squared. Plus, we can also factor the y's, which is y squared minus 2y plus 1. And the factored form will be written as quantity y minus 1 squared. And on the right hand side of the equation, we simply simplify. It's negative 52 plus 100 plus 1. Okay, simplifying that, we will get 49. Hence, we are done. The standard form of this example would be quantity x minus 10 squared plus quantity y minus 1 squared equals 49. Now that you know how to transform general to standard, let's now do the vice versa. And this is the first example. I have again written here the important concepts needed. The first one is the FOIL method, definitely, and again, operations involving algebraic expressions. So for you to be able to remember what to do when transforming standard to general, just think of the word expansion, meaning we are simply going to expand this standard form. So we start by expanding quantity x minus 1 squared. So that will be written as quantity x minus 1 times quantity x minus 1. We do the same for quantity y plus 2 squared. It will be expanded by writing it as y plus 2 times quantity y plus 2 equals 10. Then afterwards, we are going to do the FOIL method. So let's first proceed with the x terms. So x times x is equal to, let me just write it, it's equal to x squared. Next, we multiply x with negative 1. So x times negative 1 is simply negative x. Moving on, let's now multiply negative 1 to x. The product is simply, again, negative. Let me just write it. It will be negative x. And lastly, let's multiply negative 1 with negative 1. So negative 1 times negative 1 is equal to positive 1. So that will be plus 1. We now successfully expanded quantity x minus 1 squared. Let's now proceed to quantity y plus 2 squared. So same procedure, copy the operation addition. Y times y is simply y squared. Let me just write it, y squared. Then multiply y with positive 2. So y times 2 is equal to positive 2y. Next, we multiply 2 times y, and then the product is the same. That will be positive 2y. Let me write it, positive 2y. And lastly, multiply 2 by 2. So 2 times 2 is simply equal to positive 4. And again, let me write it again on the equation. So plus 4 equals, copy the right hand side of the equation, 10. After which we are going to combine like terms. So that here we are going to utilize our knowledge in algebraic expressions. So we can combine negative x minus x. And then we can also combine 2y and another 2y. They are other like terms. And lastly, we can also combine the constants. And the constants here on the left hand side of the equation are 1 and positive 4. So let's start writing those without the like terms. So that is x squared plus, okay, we are going to also copy y squared. Then simplify negative x minus x is simply negative 2x. Then let's simplify the y's. Positive 2y plus 2y is positive 4y. And lastly, adding the constants will give us a value of positive 5 equals the right hand side of the equation there. Let's simplify further by transposing the constant to the left hand side of the equation, so that we follow the general form that all terms will be on the left hand side of the equation. Hence, we'll have x squared plus y squared minus 2x plus 4y plus 5. And then from positive 10, it will now become negative 10. Lastly, the whole equation will now be equated to 0. And it is almost close to the general form, but we still need to simplify further. So copy x squared plus y squared minus 2x plus 4y plus 5 minus 10 is, when simplified, negative 5 equals 0. Hence, but the general form is x squared plus y squared minus 2x plus 4y minus 5 equals 0. Before we proceed to the next example, let me present a concept that may serve as a shortcut when transforming standard to general form. And this concept is called square of a binomial. So the square of a binomial is represented by this equation: quantity a plus b squared equals a squared plus 2ab plus b squared. So for you to be able to understand how this works, let's have an example. We have the binomial x plus 5 and it is squared. So how do we do the shortcut using the concept of square of a binomial? Step 1, you square the first term. Step 2, multiply all the terms with the exponent. Then lastly, step 3, square the last term. So when expanding a binomial, we should be having as a result a trinomial. So let's first identify where is the first term and the last term given this binomial. So x is the first term, while 5 is the last term in the binomial, and obviously 2 here is the exponent. So step 1, we need to square the first term, which is x. Let's check that, and then we square x, and that is x squared. Step 2, multiply all the terms with the exponent. So we multiply 2 times 5 times x, and that is equal to positive 10x. And lastly, step 3, simply square the last term. The last term is 5 squared. Okay, and then we simply just simplify. So the result will now be x squared plus 10x, and then 5 squared can be written as 25. Therefore, the expanded form of quantity x plus 5 squared is, okay, we can write it in this way. It's equal to x squared plus 10x plus 25. Alright, let's have another example on performing the square of a binomial. Again, we apply steps 1, 2, and 3, and we can identify that r here is the first term, given the binomial, and then negative 3 is the last, and lastly, 2 is considered as the exponent. So again, we perform the steps to perform the square of a binomial. Step 1, square the first term. The first term is r, simply square it, that is r squared. Next, multiply all the terms. So 2 times negative 3 times r, and the result will be negative 6r. And lastly, step 3, square the last term. The last term is negative 3, so that will be negative 3 squared. Make sure that you include the preceding operation on the last term. So that will be r squared minus 6r, simplifying the last term, that will be plus 9, because that will be considered as quantity negative 3 squared. That's how easily you can expand a binomial using the concept square of a binomial. Therefore, we can say that quantity r minus 3 squared is equal to r squared minus 6r plus 9. Let's now have more examples on transforming standard to general. We start by expanding the binomial, and we apply here the square of a binomial so that we can easily expand quantity x plus 3. So the first thing that we need to do is to square the first term, so that will be x squared, then multiply 2 by 3 by x, and that will be plus 6x. And lastly, square the last term, which is 3, therefore the result will be plus 9. Then we copy the rest of the terms, plus y squared equals 4. Since we want it to be in general form, we transpose now the constant to the left-hand side of the equation. We are going to transpose 4 so that the whole equation will be equated to 0. Hence, the equation will be x squared plus 6x plus 9 plus y squared equals, from positive 4, it will now become negative 4. And then again, we equate it to 0. And it is somehow close already to the general form, it's just that we need to simplify. So let's now try to combine like terms here, and what we can combine are just the constants 9 and negative 4. So we copy the rest of the equations, which we cannot combine with the others, so that is x squared plus 6x plus y squared. Then simplifying 9 minus 4 will get positive 5 equals 0. This is somehow already the general form, but let's stick to the arrangement given in our general form equation. So let's just simply rearrange so that it will be in this format. Hence, we first write the term with x squared, then y squared, so y plus y squared, then plus 6x, there's no term with y, so we simply proceed with plus 5 equals 0. And that is now the general form of the given standard form equation. X squared plus y squared plus 6x plus 5 equals 0. Let's now have the last example in transforming standard to general, and this one I think is the easiest among the 3 examples presented. So first step is to transpose the constant to the left-hand side of the equation so that the whole equation will be equated to 0. So the equation will now be x squared plus y squared minus, let me emphasize, 9 equals 0. And this is already the general form. As easy as that. Before we end, let me give you some points to remember when transforming standard to general and vice versa. So the main purpose of doing so is to easily identify the coordinates of the center and the value of the radius that are both essential values needed when graphing a circle. And we use our algebraic computational skills to perform such operations. So I hope that at the end of this video, you were able to achieve the learning objective. And that is all for this video. Thank you for watching.